Wow, that's pretty good. I haven't done anything and you're already clapping. I think I'm done. Okay, how many of you have done some mobile development before? And that, great. How many of you tried to do like multiple platforms? And how many of you enjoyed that? Yeah, as expected. Okay, cool. So welcome to my talk on NativeScript, or actually an introduction to it. So I'll give you a little bit of an insight of what it is, how to use it, how it works, and stuff like that. So a little bit about me. My name is Sebastian Witalec. I'm Polish, so it's not Witalec, like English people try to call me. And I'm a technical evangelist for Telerik, well, a progress company. And I am a NativeScript champion because I love NativeScript. It's a really great framework. And I'm based in London, and I work with various dev communities around London, such as this a bunch of groups for international developers. So we have like an English, we have an Italian group, a French group, a Polish group, and we gather together and we create stuff. Then I'm as well working with various software architects, and we have a mentorship program for people who want to become architects or who want to get better. And as well, I'm running a NativeScript Insider group in London, but that's actually going to grow into more cities very soon. All right, so today I'm going to talk about the mobile OS landscape. I'm going to introduce you to the problem of cross-platform development, and I'll give you a bit of insight into the birth of NativeScript, and as well a technical overview of actually how the whole thing works inside, and I will let you know about actually where we are at the moment with the whole development. So, Android and iOS pretty much captured the attention of mobile developers. Android has much bigger audience, while iOS is much easier to monetize. Therefore, it's very easy to actually forget that there is a third player in the game. And Microsoft recently they managed to recapture its lost ground. And about 28% of mobile developers now claim that they're developing for Windows platforms as well. And if you develop for these three platforms, then basically you get almost complete coverage of the smartphone market. However, the coverage by itself is not going to pay your bills. That's why we should have a look at the numbers of apps in the stores and the money associated with it. And from this slide, the key thing that I find very interesting is that Windows Store has 4 times less apps than the other ones. However, its total revenue is only 20% less than from Google Play. This means that we should never be really neglecting any of the frameworks. And what does this mean to individual developers is basically, if you develop for any of those platforms, you can earn between $3,500 to $5,000 a month. And if you develop for all of them, then this amount can double or triple. And without any surprise, a lot of mobile developers already recognize that and they develop for multiple platforms. However, in the last couple of years, this number has shrunk from 2.9 1.5 years ago to 2.5 12 months ago. And as of the latest report, this figure is on 2.2. And if we exclude game developers, then this figure is as low as 1.75. And you see, cross-platform mobile development is a little bit like a three-way chess game, except you make all the moves. You get much bigger board to conquer. However, the complexity increases. With every move, you have to analyze it from yet another angle. And you quite often find yourself in situations that are quite unexpected and quite complicated and take a lot of effort to handle. Yet, I still wish that cross-platform mobile development was as easy as three-way chess game. Because at least each of those pieces, they behave in a predictable and standardized pattern, while mobile platform APIs, they do not. And this creates a problem where you have to build the same solution 3 times but just for one problem. Quite often, a bug that exists on one platform may remain hidden on the other ones, or the applications that are meant to behave identically on each of the platforms may exhibit subtle differences due to different implementations. And finally, releasing new features at the same time is really hard. And why is that? Well, it's quite simple. It's because if I'm to develop for iOS, I need to learn Objective-C, install Xcode, and work on Mac OS X. For Android, I have to use Java and install Android SDK and work with Eclipse. And to be fair, like I tried Android development 3-4 years ago, and it took me a whole day to build a Hello World app, and I gave up. It was either I threw away my PC through the window, or I gave up on Android. So I love my PC because it was my gaming PC, so I kept it. Then finally we have Windows Phone. So by again, this time I have to use Windows Machine. I have to learn XAML, C#, so everything with Visual Studio. And this creates a problem where basically I have to use multiple machines, learn multiple languages, and become expert in multiple platforms. And this is really not good. Then on the other side, we have Cordova Hybrid App Development, where I could use HTML, CSS, and JavaScript and cover all the platforms. However, this comes at a cost, where we have to sacrifice the smooth and beautiful user experience that we are accustomed to. So don't get me wrong, you can still build quite amazing applications using Cordova, but there's some limits. And in some cases, this is just not good enough. So this is why we decided to create a cross-platform framework for building native mobile applications with native UI, accessing native API. And all of that should be accessible from JavaScript, because that's the common language that a lot of people know and they feel safe with. And what was the first point of call? What should be the first thing you should do when you want to build a framework? What should it be? Well, you have to come up with a name. So we came up with, we had an internal contest and we were sending emails around and who can come up with the best name. There was no prize, just pride. And we came up with Kempo.js, Visualize.js, Universal.js, and Native.js. You can see the pattern, right? But they weren't good enough because we're after much more than just a yet another JavaScript library. We have to build a proper framework. Then cross-fly, cross-file, and cross-compile crossed our minds, but we decided to cross it out. Then we also had Tronjon, J2SN, ScriptBridge, and ScriptGap. They all kind of sounded okay, but they weren't just good enough. We seriously considered Xcompile. That was like a top candidate for quite a while. But then eventually, we kept looking on and we found the one and the only NativeScript. Basically, it's a framework that allows you to build native mobile applications using native UI with just JavaScript and no excuses. So, how about I do a little demo and show you how it works. So this is going to be sort of like live coding, but out of experience, I'm actually going to follow a few patterns. So what I have my phone here, which I have a nice tool that can actually mirror and show you what I have on the phone while I build the applications, just to give you an idea. And that should appear very soon. Here, that's my phone. These are my shoes. The trousers actually I'm wearing now today. Okay, so what I can do is basically, I already have a NativeScript project, and one of the first things you normally do, you go and build the project after you create it, and you can either do it for Android or iOS, and there's two options, and then one of them is a companion app. It's basically an application you can download from public stores, which helps you connect with your project, which is really cool. So what normally you can do then is basically, let me go back to the side thing. I can go and scan the QR code in front of me. So I can go scan. Yeah. Scan it. Oh, yes. And what I just did now is basically said, okay, find out, I want you to connect with my project. So every time I'll be making some changes to the application, I can just go back to the compiling app and just make changes. So how would you go about creating a hello world? You remember I took a whole day to build one for Android. With NativeScript, it's very easy. It just takes minutes, seconds. I just go create, write hello world, an XML file. I'll explain a little bit about it. There we are, and then call sync. And that just basically goes, pulls the code from my application, and here we are, hello world. Wasn't that hard. I think we should probably make the font bigger. Can you guys see what I'm typing there?
No,
not really. That's what I thought. There's an option. Sorry for that. I should have remembered. Better? Better or not good enough?
not good enough.
Oh. Demanding people.
We are flying.
Seriously now. Yeah? It might be too much for me when I get more code later, but hey. So one of the things that you can notice here is we're using XML Structure to define how you lay out your UI. And basically the reason why we did that is, well, Android does it, and then Windows Phone, you as well use XML Structure to do that, so we thought, well, why not for us to do it? And a lot of people know XML, it's just a matter of learning which tag to use what. And if you want to add a button, well, guess what? It's called a button. It's that simple. So Hello World is never too impressive. What else I can do? I have this example, number one. What I would do is just basically comment out different sections of code to give you an idea. Then you refresh it, and then I'll talk about it. So save it. So the next application is basically a very little form where we just say, okay, I want to put like a registration form. So it's Sebastian, ABC, whatever.com, and my Twitter handle is Sebavita. I can call sign up, and that does something. And the way it works behind the code is we have two sections. So again, we have XML with description of the view, where I can say, okay, I have a label that says name, I have another one for email, another one for Twitter handle, and then I have a text field that basically is just this placeholder here, here, here. And I gave an ID to each of them so that in my code behind, I can actually go, see now the code is too big. Okay. So that I can actually go and then retrieve each of the controls and then edit them. So I can go and say, okay, set the text file to this or retrieve that. Obviously, this is not the best way to do it. I'm just showing you that it is possible. It's one of the ways. And then finally, we can assign, there's this assign a button, this button here. So we can go and then give it a function. So it's just, if any of you understand JavaScript, then this is just plain simple. This is what you will do in a web browser as well. It's just like, okay, if my text fields are not empty, then basically write success and a message. If any of these empty, just display an error. Yeah? I mean, this is just the beginning. So the next step that we can do is basically, and that's where it gets a bit more interesting. Let me close those. So we have this form. I'll spend a little bit more time on this one. Cool. So we have this form for calculating how much would it cost you to drive from one place to another. We have distance, efficiency of your car, and then the cost of fuel. Did anyone drive here today? Yeah? Okay, you. How far did you drive?
6,500 kilometers.
3,000, wow. Where do you live? Portugal?
London.
London, okay. Did you drive from London?
Yeah.
Can you give me a lift back? What's I live in London. What's the efficiency of your car?
Liters per 100 kilometers, 10.5.
Expensive car. And the fuel cost in here, I checked last night, is 1.22. So I can go and calculate, and that costs you 450 euros.
Yeah.
Did you consider flying? Yeah, that's true. Sorry, I'm just kidding. But the whole idea is like, again, like the XML structure is very simple. What we have here is, for each row, we have like a label, text field, and a label. But we'll come back to that. What I did is, we start playing with bindings. So rather than actually go in and say, go find that text box by this ID, and then retrieve the text value, we're gonna do it the other way. Where we're gonna just create our data structure first, the logic behind, and then make the UI responsible for communicating with our data. So the easiest way to do it is we can create a very simple JavaScript object, which will give us already half of the story, where whenever you change the data in the view, this will automatically get changed in our code behind. So we have this object that is basically called journey info, and we have three attributes: distance, efficiency, and fuel cost. And then we have, when we load the page, we set the binding context of the page to that object, which means that whenever we are on that page has this object that is used as a source of data. And it's quite cool. And the next thing that we have this function that is used for calculation. It's very simple, you know. You calculate cost per kilometer. Well, it's the fuel cost times efficiency divided by 100, because that was the measure you used. And the same thing for journey cost. Well, it's distance times time the cost per kilometer. And the best thing is that we do in here is like the function itself, because it doesn't have to go to the view and say, hey, this and this text box, give me the distance that somebody typed. The JavaScript class owns its own data, so it doesn't have to go begging to the UI, because UI is responsible for something else. And then how we connect these two is basically, if we have this this journey calculator, we use handlebar notation. So we have now a text field where we say the text value should be bound, and you use this open brackets, then you provide the attribute, and then you close the brackets. And that creates a binding between our data object and the view. So whenever we type it here and change efficiency, so let's say you're driving a Peugeot, you'd save yourself 150 euros. But that's the whole thing of the binding that they communicate with each other. And if any of you ever work with WinForms, you know how painful it is to remember all the IDs of all the bloody text boxes and stuff. But the problem is that in order for me to update this label with the result as it is, I still have to go and then retrieve it from the page by ID. Because just the plain JavaScript object doesn't have the mechanism to push back the changes. So if I go on and make changes in the code behind, the UI doesn't get notified. That's why what we need next is an observable object, which basically closes the story. So what I have here, as you can guess, another example, and this is the proper way already of doing it, where we're going to use the MVVM design pattern. Any of you use MVVM as that? Yeah, you love it then. It's great. So here's the idea. Where we have 3 files. And I'm going to load it. It's a game, so now you all get to play as well. Sync it. And it's a very simple game where we have numbers from 1 to 10, which are ordered in randomly. And basically we have few functions. We have a new game button to start the game, and then here's the current value. And you can either decide to go lower or higher, and then you get points if you get it right. And so let me show you how this whole works. Where are we? We start with the view model. So what what you normally would do is first thing, you get yourself an observable object. And as well in NativeScript we use require in order to get any libraries or any classes that we need. So if you have a module for something, you could actually go and require it. And if the module requires initialization, require will make sure that this initialization just happens once. It doesn't have to happen 500 times, especially if it's something costly. So first thing, we require an observable module, and using that module, we create ourselves an observable object, which is in this case, up-down view model. Let's start with our buttons. So in here, I have a start new game function with just basic JavaScript code. There's really no magic. Then we have a function to go higher, and we have a function to go lower. And then what we have to do at the end is basically just say export the view model as the up-down view model. Yeah. So this view model itself, this file here that I'm showing right now, is a module by itself, which means that then if I go to the code behind of my file, I can go and require it. Yeah, so I can require my view model, extract the view model object, and pass it in as a binding context. Having done that, now I can go to my XML and start doing stuff. So you see we have a button here with text field and new game, and then on tap event, we have the start new game. So basically what this means, if I click this button to binding context, we'll go to the view model and we'll execute the new game function. And the same thing is for lower and higher. And some other things that we can do is you can use expressions inside the bindings. So we have this expression here that says cards left, and then add the cards left attribute. So you can actually make it more complex than that. It's pretty much like following the handlebar notation. So if you know it, it basically has as it should be. Otherwise, you can just read up on it. And then that's pretty much for each of them. The problem is that each of those apps that I built, well, it's not a problem. So the first thing, each of those apps that I built, like this button and those labels and all that, they're actually native. They're not, this is not a web view. So if you were to get into like an Android inspector on my phone, you'll be able to actually see Android UI structure. Which means that if you're building a very complicated application with a lot of elements on it, and you start swiping and scrolling and everything, there won't be any lag. Because this is native UI, and both for iOS or Android, they're actually designed to handle their own UI controls, as opposed to in some cases when it comes to a web view. But this app, as it is, wouldn't sell. Would you buy this game? It's a great game. It's a lot of fun. They give you about 5 minutes of fun every day, but you wouldn't because it's ugly. So, as the next step, what we can do, and I quite like it. I'm not a designer and I'm not good with visuals. But what we have is we have the concept of CSS. So we kind of follow the idea where, let me just hide that. We follow the ideas of like the CSS. This cuts off a bit. Let me move it a bit. Yeah. So we follow the ideas of like defining how your application should look from web. So pretty much all of you will know how CSS works. You might not be experts, but you have an idea of how it works. And we did the same. So I have a class for info and info label. So basically, let me reload it, and you'll see where I'm heading. And the same thing, for example, I have one for button. So I say the button should be bluish, and the font should be bigger, and as well, the card is this element here, and it should be red, and it should be visible, so that if I'm in the middle of a massive crowd, I should be able to play my game with you. So let's test the game. Let's start it, and I want to hear. Should I go lower or higher? Come on, anyone? Huh? Higher. Ooh, risky. Let's see. No. Next one. Higher, lower. We have 8 more. Quick. Higher. Okay. No. Higher. Higher. Okay. Lower. Higher. Lower. Higher. What's next? Lower. I want to feel like a machine gun. Quick, quick. Higher. And lower. 20 points. That's pretty good. That's pretty good. All right. So, how the CSS applies to the application is we can add it in XML. So what you can have is like if I have a label that I want to use it for, I can do what I can do is say CSS class equals and then pass in the class we're going to link it to. So automatically this reads from our CSS and then transforms our application. You see, we don't have anything on the buttons because we use like a global definition saying all the buttons, unless they have the class of their own, they should all look like this. And the best thing is that you can actually take an existing CSS file from a web project and drop it there and it will work. The only thing is what's going to happen with the attributes that are not implemented. Well, they just get ignored. So if, but for those that we implemented already, they work out of the box. And the idea is that what we have to do is not that it is CSS by itself, but it's like a translation. So we're trying to look for the common denominator, and then for all of that, like changing the color of the button, there's a code behind in JavaScript that kind of goes, okay, when loading button, go and change the background attribute to make it look like it does. And some of the other things that you can do, like we use a naming convention. So basically, the way we know that there is a CSS file for this view is basically because our CSS file has exactly the same name, it's just a C.css extension. If you want to have a global CSS, then basically you just do the app.css. So app.css is global, and then for specific views you can create your own by using exactly the same name as the view name. Another thing that you can do that this example actually doesn't show, but you could create two different views depending on which platform you are. So following the naming convention, what I could do is create another XML file that basically will be something like .ios, or I would have another one called .android. And then depending on which platforms the application loads on, you either use this view or this view, which means that you could have some applications that share views across all of them, and then you could have some views that are actually specific to the specific platform. So imagine you have a page where you're showing a map, and there's a different map for Android and there's a different map for iOS, and then in this case you might want to have a different script. And that's the idea. So there's a conference in Boston in May, and we're running a 6 hours workshop there. And for that workshop, we built an application that is for creating memes. And let me show you the application. So you can actually do cool stuff with it if it works. Yeah. So it's an application where there's already like some predefined templates. And if you don't want to use any of those existing ones, what we can do is just go and create your own. That should load the camera eventually. Yeah. I think sightseeing is blocking it. I'll do it offline. And I'll show you what it's doing. Let me reload it. Okay, while this is loading. Do you guys have any questions to the demo part? Because, yeah?
Oh,
Do you have a question?
yeah, I do. I saw on the last video the meme app that you have some animations. My question is how you do animations with this? Animate button, for example.
So that's actually just a property on navigation. So I can load up the code. Oh, that's the wrong project. So what we have even a navigation module somewhere in shared. I could see it. So I'm blind at the moment. Oh, here it's shared. We have a navigation module, so there's a module that helps you do the navigation. And then what you can do is say, when you do navigate, you can say where you want to navigate to, and then you can tell it like to navigate or to something. And we keep adding new attributes so that you can choose what sort of animation you want to add to it. And the idea is as well that if there's a native way of doing the navigation or doing anything natively, then you can actually just access it from there. And I'm going to explain how it works internally in a moment. Yep.
Yeah, I have a question related to the formats you're using. I don't understand why you use XML and not HTML. So that's the first thing. Your XML seems to me quite convoluted with camel case names, and it reinvents a little bit the wheel. For instance, the class attribute, you call it CSS class. Why not class? Just class. I mean, in like XML and HTML. For instance, in your example, there was a stack and buttons and labels. For me, that's a div and a paragraph and buttons. Why don't you use HTML5?
Well,
and same thing, the attributes to bind the behaviors. You have this curly brace, go lower, I don't remember. That's to call a JavaScript, NativeScript, as you say, a JavaScript function. Why don't you just put JavaScript? Go lower parentheses. Please explain the design choices. I don't understand them.
Okay. So basically, all HTML and XML that was even like it's actually an ongoing battle. But the reality is that this is not HTML application. There is no web view, and eventually we decided to go against HTML because that would bring a lot of confusion, where people would go like, okay, since this is like HTML, I should be able to create HTML. And we had too many people were trying out that actually tried to do like create a website more than an application, and that was creating a lot of issues. And in reality, the structure is almost the same. It's just we use different tags because we don't want people just use exactly what they did in their websites, because we want you to actually think about how you build the application. That's as well, like that was how it was explained to me, because I wasn't 100% sure which one is the best. And like in reality, there is no black or white. That's the difficult thing. And as for not putting JavaScript inside there, that's not 100% sure that it will never be possible. So at the moment, we prefer just go with bindings, but in the future, it might be possible to just add JavaScript code there. It's just not there right now. Okay. Actually, can I? Because I have still a little bit of the session, and I'll answer more questions later, if you don't mind. Yeah. I'll just take a picture and I'll show you what I can do with the meme thing. Hello. Oh. So that should load up anytime soon. So if any of you wants to learn how to build this application, you can join us in Boston. It might be a bit tricky. Where it go? Sorry. That was always that difficult. No. Okay. Machine said no. I'll do it at the end, show you what I try to do. Okay, cool. So I just want to, so now what I'm going to do is just explain you how this whole thing works internally. And I need to, here we are. Go back to my presentation. Great. That's gone too far. Cool. No. That's not what I want. Why Right, don't touch it. So NativeScript is not just a set of libraries, but it's more of a runtime that uses JavaScript virtual machine to execute your code. And for Android, we're using Google's VA JavaScript engine, and then for iOS and Windows Phone, it is WebKit's JavaScript core. And the way it works, basically, we use the JavaScript virtual machine to interpret and execute your JavaScript code, and any references to the native API are then delegated to metadata, which is basically a whole library of all available API call functions and types within the platform. And then this then gets passed on to type conversion that translates JavaScript objects into native types, and then in reverse later on from native to JavaScript. And then finally we have a call dispatcher that executes the actual call. And to put that into context, let's use an example. And this is an example of how would you use JavaScript to call Android API to create a file object. So V8 will go and evaluate this line of code. Type conversion service will take path and translate it into Java lang string, which is a native string object. Then the metadata will go look up the native API and finding the native constructor for the file object. And then finally the call dispatcher will execute the call, and this will result in like a dual result. Well, basically on Android side, what we get is a native Java file object, while on the NativeScript side we get a JavaScript custom proxy type object, which basically links to the native one. So whenever you make a call on the proxy object to do something, that gets delegated to our native object. But that's just like the core of the foundation of how NativeScript works. And obviously, using JavaScript to call each of the native APIs is not an answer, because then you still end up writing the code 3 times. And that's why we have this thing called the NativeScript modules layer, or NSM layer. And NSM layer in reality allows you to write your code once on a higher level, on a higher abstraction layer, and this translates it for you. So whenever you want to access files or any of the specific modules, there will be, or components on the phone, there's modules that help you do that. And then at runtime, this gets then translated into a platform-specific code and then executed natively on each of the platforms. So coming back to our file example, basically this is slightly different code, so that's how you would do it using NSM layer. And then when you call it, this will result in calls like that. So now having the NSM layer, you don't have to think about how to do something, but what you want to do. And then trust that the NSM will take care of it for you. So you don't have to learn yet another implementation on how to open a file on Android or on iOS. And then when we add Windows Phone, you don't have to think about how to add it, because the layer will do it for you. And this is basically the idea, is that what we're trying to do is solve one of the biggest problems of cross-platform mobile development, where you have one code to rule them all. And that's the idea. And obviously, having heard how the whole thing works internally, you might be thinking like, well, how's the performance like? What's the penalty of having all those layers and all those abstractions on top of everything? Well, we were wondering the same as well, and what we did, we created a few applications. We built them completely natively, and we built them with NativeScript. And then using various techniques, we compared the performance of one and the other, and we found that the penalty was about 10%, which in most of the cases is not even noticeable. And even though 10% is lower than we initially expected, we still work on it and try to make it better every day. So if we're running some experiments right now, and if they work, we might push it for the next release. So the current state, we have debugging that you can actually debug on device or inside emulator, and it's almost no setup required. We support iOS and Android, including 64-bit iOS applications. Windows Phone is not available just yet. That will take a little bit longer. Then you can use native third-party plugins. So if you have a native, let's say UI component for a calendar or a bar chart or something, you can add it to the project and start using it. You don't have to wait for us to implement it for you. There's a new documentation portal which has all the information and examples on how to use each of the components and what sort of things you can do. But most importantly, this is open source. And we licensed under Apache license version 2. And the whole idea was that we didn't want to create yet another closed source framework, because goodness me, there's quite enough of those already. But what we wanted to do instead is actually build an application with the community, with the mobile developers, with people who actually use the framework to make something amazing, something that works, and all of you would want to use it. And if you're interested, you can actually go to github.com/NativeScript, where the code is already hosted. And then finally, if you would like to get involved, you could email Valentin Stoichev, who's the product manager, and he'd be quite keen to talk to you guys. Then there's an insiders group, which you can find on NativeScript insider sign up, just like here. And basically, this is for people who want to actually contribute, who want to add information or kind of help out, or maybe even build something. Then you get extra attention if you go that way as well. And if you're around London, maybe you could join me. We have like monthly, bi-monthly kind of meetup sessions where we gather together and we talk about stuff or try to build things together. So the workshop that I will be running in Boston in May, I'll be running it in London as well. And what I wanted to say, any of you would be interested in creating one for Sofia, I'll be more than happy to help, and we could do something together. Because it works quite well in London, why not to do it in Sofia, This is the Silicon Valley of Europe. So let's show the Americans how it's done. So, any questions?
Okay.
Welcome. Yeah.
Hi. Thank you for the presentation.
You're welcome.
I mean, it's good to know that there is someone that takes care about the developers and try to make their work easier. But for now, as I saw, actually, this is kind of more similar to AngularJS combined with Cordova. At least there's not something new for me. If you know how to write good HTML and CSS, then the screen translation is not going to be any problem, even if you are using multiple web views or only one of them. So I'm not seeing the benefit. I mean, maybe in the future there will be, but at the moment.
So the benefit is the limitations of Cordova. Because yes, if you're a very good developer, you can do quite a lot of things, but there's some things that you just can't be done. Or did you ever try to write a plugin for Cordova? Yes. How easy is that? From 1 to 10, 10 being difficult.
Well, at least 5.
At least 5. Well, yeah, my experience will be around 8 or 9 for myself. With NativeScript it's much easier because, like the first mechanism that I explained, if you add something and there's a native layer to access it, it's literally you start writing the code against it. And being able to integrate with stuff that are not part of the framework by default, or things that are coming from outside, is one of the biggest benefits. And as well, because the UI is actually native, you get the best performance possible, not just a web performance. I mean, Cordova is great, but there are limitations. There are just some applications, and if you talk to guys from Facebook that try to use Cordova, they moved on to native because it wasn't just enough. So, but these are the main things for me.
Yeah. So one of the I'm back to the XML problem. I think you were expecting this, right? The two other XML languages for UI that we know are Zool in the Mozilla world and XAML. Okay, Zool has an incredibly powerful feature that is you have a DOM. I mean, your UI is in XML, but your JavaScript can insert an element in the DOM, so your UI element just appears immediately. Okay, you can move the elements inside the DOM, and the UI is instantaneously updated. And I wonder if you can do that in NativeScript, or if you use the XML only as an input format. You parse it, generate the code, and it's forgotten, and you cannot play with the DOM.
So,
Because if you can't do that, I don't understand the use case for XML.
okay, so yes, you can. So the idea is that anything that you can do in XML, you can do in JavaScript as well. And NativeScript has a DOM, which is not like web DOM, but it follows the same pattern. And you can add like dynamically
With the
components.
same methods, append child, remove child, get by ID,
not
it's a normal DOM?
It's not web DOM. It's not exactly, I can't tell you the syntax from top of my head, but follows exactly the same principles. And this is the idea that we try to follow, that basically DOM worked quite well for web, and we have something similar, except we're trying to put more performance on it.
So hence my corollary question triggered by your code. It looks like you're reinventing the wheel again. I mean, it's like the DOM, but you're not using the same methods. So it's a learning curve problem. People have to learn a new syntax, new names, new properties, new attributes. Why don't you use the standard?
Well, the first reason is like because there's already one, which is Cordova. Like the gentleman there over there uses, and the thing is that it's not enough. It just doesn't work. There's some cases that it's not perfect. And to be fair, this is like even a longer conversation. It's like I was saying before, not a black and white answer. It's definitely more of a debate than being able to kind of say this is exactly it. And there's merit to what you say, absolutely. There is a learning curve, and there's something that you have to learn. But nothing is ever easy in life. That's the fact.
Last question, very quick.
Hi, thank you for your call. Just ask, can you use any ID to develop with NativeScript, or you need some specific Telerik platform ID or something?
Okay, so there's two. So yeah, one you can use it in Chrome, which uses Telerik platform, or the one I was using there. There's a Visual Studio extension if you want, and there's as well a command line interface. So you could actually go and just execute everything locally. And then you can connect. There's even a direct connection for Sublime Text with the CLI. But if you want to use your own tools for, let's say, in Eclipse or something, you could just add commands. And this is just very few commands. You guys have like create project, build, sync, and this kind of thing.
Okay.
But yeah, it is available.
Thank you.
Okay.
Thank you very much.